In this problem, we're asked what is the differential node voltage gain, ADM, in V over V from the differential input voltage. We have our VIDM, and that's equal to V2 minus V1, and we can get that from the notes over here. So our V2 is equal to, our VIDM is equal to V12 minus V1, and that is our inputs here to the output of the operational amplifier circuit shown. We can assume our op amp is ideal and use the fact that R1 is equal to R3. So we'll put this right here. R1 is equal to our R3, and then our R2 is going to be equal to our R4. And so we have that as 3.2 and 2.1 kilo ohms respectively. Now we need to find our AIDM. That's what we want to solve for. And we know from the notes linked below the like button to the right, our AIDM is equal to our Vout over our VIDM. And we know our VIDM is just V2 minus V1. So now let's solve for Vout. And well, we can do this using our superposition right here. Superposition. And so with the superposition, we're gonna do like a step one right here. And we're gonna solve for the output for the first part. So we have our V output 1. And this is just gonna be V1. And so our V1 is going to be equal to, we're going to have our V input. Again, this is the output because our VIDM here deals with output. And if we look at the notes, we'll see up here that it's the difference between 2 points. And so we have our V1 and our V0. And so inside of here, we have our V inputs right here. So we have V input 2 minus V input 1. So actually this is wrong, and it's V input 2 minus V input 1, hence that these are both input. And so with those input, we can go back down here and we're going to look at this. So we have our V output for the first one. This should be output, and it's going to be equal to our kind of source, which is the V1. And then the way we have this part is the R2 part is that this is going to be, we're going to have some negative feedback like this, and so it's going to be multiplied by our R2 over R1, and I believe because of the negative feedback we're going to have a negative sign out here. Next we're going to have our second part, and for the second part we have our V output 2, and it's equal to the V2, which is just the input, so we're going to have V2, and then in here we are going to have our resistance. In our resistance here, we are going to have the R4, kind of like how we had up there, but in this instance it's R4 over R3 plus R4, or R4 plus R3. That would probably be a better, cleaner way to write it. Now after this, what we're going to have, because of our superposition, we're going to have 1 plus our R2 over R1. And so in here, if we see that these have our equivalents as being R1 and R2, with the R4 being equivalent to our R2 and the R3 being equivalent to R1, if we make it like this and we do some calculations, so basically we will be inside of here, we're going to say that okay, we want to combine, we'll do this part first. So we're going to have R1 plus R2 over R1. And this is going to be multiplied by our R2 over R1 plus R2. And we can see that these are going to cancel out, and we're just going to be left with R2 over R1. So we can come back in here, and we can say our V output 2 is equal to V2 times our R2 over R1. The superposition part's a little tricky, but we are just really using the following right here to solve for it. And so with that in mind, we know that our V out, the total V output, is just going to be equal to the V output 1 plus V output 2. So in step 3, we'll have V output is equal to our VO2 plus VO1. And so in here, we can see that we have like terms, R2 over R1, R2 over R1. So we're just going to factor these out, R2 over R1, and then we're going to have our V2 minus V1, because we have our V2 here, then negative V1 here. And so with that in mind, we can plug this back in, right? Because this is equal to our V output. This is what we wanted to solve for. And we want to plug this in right here. So we can say that we have R2 over R1, and then inside of here we have V2 minus V1, and this is over V2 minus V1. And so these are obviously going to cancel out. And all we're going to have is our R2 over R1. And so we're going to take our 2.1 kilo ohms and divide it by the 3.2 kilo ohms. And if we do this, we're going to get an answer of approximately 0.66. And that is how we would solve this differential mode voltage gain with the notes linked below the like button. That's how we would do any problem like this, even if the values are changed. But here's the basic concept.